Well, thank you very much for that introduction. That was great. And today, as my presentation title suggests, I am going to talk about kind of the occurrence of toxins and continue on from what Dr. Lilburn said in terms of emerging toxins. Also talk about the effects on poultry and a little bit of management, but overall really relate this to maybe the idea or the concept of mycotoxins as an anti-nutritional factor on the birds. So of course, you all know this, anti-nutritional factors, they are secondary metabolites from plants. They do provide a benefit for the plant in terms of protection, and they do have adverse effects if they are consumed by the animal. So mycotoxins, we can also relate in the same way and really check the same boxes because mycotoxins are secondary metabolites, although they're produced by fungi, not plants, but they have a role in many ways, some for protection, some as adaptation, maybe a stress response, and they do have very similar harmful effects on the bird. And so we'll go through those in some upcoming slides. But first, I wanted to go over sort of, do we have to worry about toxins? You know, it's been indicated they're prevalent and they're out there, but really, how occurring are they? So we have actually what we call our Alltech 37 Plus laboratory. This uses UPLC MS technology. Our primary lab is located really just down the road outside of Lexington, Kentucky, but we do have a secondary one as well in Ireland. And globally, we are able to test samples that are coming into these labs. This is an example here for global corn. And you can see that for broilers, there's low risk, there's moderate risk, there's high risk. This is since 2018. So really you have a chance of getting any number of risk levels for mycotoxins in the corn. But what I think is interesting is when we look at almost 5,600 samples here and over 37,000 data points on mycotoxins, we do see that multiple mycotoxins are the norm. So on average, there's 6.7 mycotoxins. And you can see actually some of the samples went all the way up to 47 different mycotoxins in that corn. And then what's also interesting is that you can see here in this bar graph that the number of mycotoxins per sample maybe is slightly increasing. We see since 2018 about 1 mycotoxin on average increase per corn sample. So maybe a slight increase over time. We can also look at the breakdown of the groups of toxins. And we can see clearly that group in orange, that's the type B trichothecenes. That contains deoxynivalenol, or you might know it as DON or vomitoxin. There's that mycotoxin plus its family members. That's a large portion of the samples. We see the group in gray, the fumonisins. That's also globally a very commonly occurring mycotoxin group. And then this other group here in blue and green, those are the emerging mycotoxins. And we can see that actually they make up the biggest portion of the mycotoxins that are detected. So in 31.4% of the samples in these corn grains globally. And actually that number has increased over time. So we actually have about a 6.6% increase since 2018 of these emerging mycotoxins. And then we can also compare maybe the difference between emerging toxins and the sort of key parent, mycotoxins like aflatoxin and deoxynivalenol, where here's in the orange is a depiction of the occurrence rate of deoxynivalenol. And you can see here over time, it has remained fairly steady in the occurrence rate in corn globally. It maybe even slightly has decreased. But if we compare that to the emerging mycotoxins, we have in yellow the enantians and in green maniliformin. And here we can easily see a very steep increase in the occurrence rate in this corn of these emerging mycotoxins. And it's not just the occurrence rate, we can also see the averages and maximum levels increasing as well. So in gray, that's the average of maniliformin, and in red, the maximum levels. And we also, again, see these sharp increases in the levels that are being detected. Now, why might that be? First of all, some of these emerging toxins can be produced by multiple different mold species. So we have, say, DON. DON's produced by Fusarium graminearum, and it's really just focused on that one mold species, whereas maniliformin can be produced by multiple different Fusarium species. And so that opens up to so many different regional production, so many different climatic conditions that can be, that these molds can grow in and produce the toxin. It also allows these molds maybe to be more adaptable to the environment. And this particular toxin is also suggested to occur more during hot and dry weather, which certainly the past couple years in some regions of the US as well as in Europe have been very hot and dry. So the other thing I want to kind of bring to this data is the way we look at risk. And this chart on the right, so the table showing the numbers, that's again the data from that global corn, just looking at it by the group occurrence. And again, there were 6.7 mycotoxins on average, showing that multiple mycotoxin contamination. And we know here there are multiple toxins, and so to get the best picture, we would think we would want to try to get as much testing as we could out of these samples. And what we've done here, and if we look at only aflatoxin, actually, if you were going out in your mill and you say, that's my most regulated mycotoxin globally, I'm going to test aflatoxin, you'd see that you might actually be, by estimating your risk, by about 94% under that real risk, because you're only testing aflatoxin, and we actually find that it only shows up in about 9% of samples. So you're missing all those other toxins. Now, if you test for just DON, that could get you a little bit closer to your true risk, because DON is a more frequently contaminating mycotoxin. If you do DON and aflatoxin together, again, maybe a little better. If you add 4 mycotoxins now, you're increasing that estimation. You're getting it more close. So if you do aflatoxin, DON, T2, and zearalenone, you're about 40% underestimating the true risk. And then 6 mycotoxins, so adding in ochratoxin and fumonisin, you can actually see that now you're only about 28% underestimation of risk. So how you test for your mycotoxins is really going to determine the risk that you perceive in your grains and your finished feeds. And the more you can test, the more number of toxins, the more frequent you can test, you can get a better picture of the true risk. So now if we know mycotoxins are out there, we've seen that in the data for this corn, and of course we find mycotoxins in really all feedstuffs globally, all finished feeds. What happens when the birds consume these toxins? And I think just before we talk about these effects, it's really interesting to see this slide here. This is showing the number of publications over time on the topic of mycotoxins. And you can see it's remained fairly steady for quite a long time, and then in about the past 10 or 15 years, it's dramatically increased. And because of that increase, now we're learning so much more about mycotoxins. We know more about lower levels of toxins. We know more about the emerging toxins and about what mixtures of mycotoxins do. And so with that information, we can then collectively say that we do know that mycotoxins are causing negative effects in the birds. The gut health would be one of the key areas. That's where mycotoxins are consumed first by the bird in their feed. There's going to be a lot of negative effects there, but also the immune system, the reproductive system, and of course overall growth and performance. And the way that mycotoxins impact the birds is going to vary on quite a lot of factors. We know that the dose of the mycotoxin, so the concentration they consumed, the mixture of mycotoxins, and how long they're consuming that mycotoxin challenge will certainly impact the response. The administration route, so naturally contaminated feedstuffs, actually have been shown in research to have a greater impact than, say, like an oral or a pure toxin dose. The species, the sex, the physiological status, so young birds, breeding animals, they typically are more sensitive than the growing animals, and there also could be changes, say turkeys might be more sensitive to certain mycotoxins than a broiler chicken. And then also health status. We know that if the animal is already challenged by other stressors, the mycotoxins could make that challenge worse. Now, when we think about all the effects that mycotoxins can have on the bird, we can kind of divide those into 2 areas. Maybe the direct effects, where we have those changes to the gut health, the damage to the organs, the changes to the performance or the efficiency, the changes to the breeding production, even mortality rates. Then there's also the indirect effects, which are certainly harder to measure, but we know that they exist, where the mycotoxins can have maybe an effect where there's an increase in gut pathogens. Maybe E. coli or Salmonella is increasing when mycotoxins are present. Also vaccination failures. That can increase when mycotoxins are present because of the suppression on the immune system. And then even changes to the offspring health. So if that breeding hen is consuming mycotoxins, that could actually be an effect on that growing embryo, and that can really set up that chick's life to maybe be not reaching its full potential. So if we first look at the gut, this is obviously our nice healthy gut picture. We have the nice mucus layer, the nice villi structure, the nice tight junctions of the gut. But when mycotoxins are present, they actually can cause a lot of disruption to the gut system. So they can affect the goblet cells, which then in turn affects the mucus layer. Once that's been changed, there's also effects then on the villi structure, lesions occurring. Many of the mycotoxins influence protein functions, and so those cells of the intestinal tract can't repair as well and grow. There's effects on tight junctions, so those cells can actually split apart more easily. And so once all those things happen, not only can the mycotoxins have a greater effect, but then that allows for the other negative or problematic pathogens to actually take over much more easily. We can see some examples here of some of these effects on mycotoxins. So here is our pictures of the villi structures with dawn at a little under 1 ppm. And we can already see that there's a significant effect on the villi of those birds. And then we can also see here in the orange bar, when mycotoxins are fed, that there's a reduction in the goblet cells in the intestinal tract. So there's certainly effects, and these are happening even at very realistic doses of mycotoxins. We can also look at the effect here of how mycotoxins can interact with gut pathogens. This is research looking at Clostridium and the occurrence rate of necrotic enteritis. And what you can see here is when Clostridium was challenged alone, of course those birds did develop necrotic enteritis lesions, about 20% of the birds. When dawn was fed alone, there's no necrotic enteritis lesions. There shouldn't be those lesions without the pathogen, but when you put those together, that actually almost doubles the number of animals that have these lesions. So you're almost 50% now. And so together, the mycotoxin, the dawn, and the pathogen are working kind of synergistically, additively together to have these effects on the bird. Another thing we can look at, if you remember back to that kind of slide about the anti-nutritional factors, mineral status is, and mineral absorption, utilization, nutritional status is one thing that can be impacted by mycotoxins. And here's an example looking at the calcium to phosphorus ratio in the bones of the bird when they were fed dawn. And you can see here that even at their lowest level of 2.5 ppm dawn in this research, they did show a reduction in this calcium to phosphorus ratio. There was also a reduction when they measured just the calcium ratio as well. We can also see that the occurrence then of leg problems can increase. So this was a trial looking at a mixture of mycotoxins that were all at very low levels, but in this yellow bar here where mycotoxins were fed alone, you can see that there's an increase in the leg problem occurrence. And then also again, the anti-nutritional factors, they tend to have an impact on hormones, and mycotoxins can do this as well. This is just one example. There are other examples here, and in interest of time, I just kept it to this one paper, but you can see here that laying hens that were fed zearalenone at 250 or 750 ppb, that at both levels, there was a reduction in the follicle-stimulating hormone and the levels of progesterone. So zearalenone is a mycotoxin that is very classically thought of as a reproductive affecting mycotoxin because it does impact hormones, but we can even see this happening in some of the other mycotoxins as well. The immune response, as I mentioned, there can be changes to vaccination efficiency. So we can see here, there's research that's been done looking at how mycotoxins interact with a number of different vaccinations. In this bar chart here, we see fumonisin and the Newcastle disease virus vaccine titers. And we can see here, even at what we would consider very common levels of fumonisin and maybe well below what you are considering as regulatory levels, that you start to get a suppression in the titers. And by 10 ppm fumonisin, now there is a significant reduction in those vaccine titers. So those birds are having an immune suppression, the vaccines aren't working effectively, and now maybe they're still going to be exposed and not protected to that, against that disease. And then finally, bringing that all together, if we think about all these sort of internal effects occurring, we can also look at performance. And certainly, even at common levels, mycotoxins can have an effect on suppressing gain of the animal, changing the feed efficiency, and on the laying hen side, we can also see changes to the egg quality as well, and the production rates. Now, I did mention that emerging mycotoxins were so frequent, so I think it's important to say just a little bit about some of the research on them. And I'm just going to talk about two of the emerging mycotoxins here, one being fusaric acid. And as I mentioned, these emerging mycotoxins can be produced by many different species of molds, and we find them so frequently. Fusaric acid globally is the one we find most often and in almost every different commodity and finished feed. And we can see here it can be produced by over 12 different fusarium molds. Now, this mycotoxin has a role in tryptophan metabolism. It's also been shown to act as a chelating agent, which then causes problem with bone formation, and it can have a synergistic relationship with other mycotoxins like DON and fumonisin. And so we can see in this example here, looking at the percent of the dead embryos by day 21, if we add DON and fumonisin and fusaric acid individually, they do have an impact on increasing the percent of dead embryos. But when you put them together in this orange bar, you can see that effect starts much sooner, so at lower levels of the mycotoxins, and it is a much greater impact. So together, these mycotoxins are increasing the response in the animal. It might be a 1 + 1 = 2, or maybe it's even a 1 + 1 = 3 or 4. Maniliformin is another one I'm going to mention here. Again, this is one of those mycotoxins we've seen quite a dramatic increase in over time. If we go back to the beginning of the presentation, there was an increase in the occurrence rates, the averages, the maximums. And this also is produced by numerous different fusarium. Over 6 fusarium species, and perhaps even 1 penicillium species can produce this mold, or this mycotoxin. And this one really has a key effect on causing heart damage, and actually poultry are thought to be the most sensitive to this mycotoxin. Whereas typically we might think of pigs maybe being more sensitive to most toxins, maybe horses, but this one really is one where poultry seem to really be the most sensitive. And then finally, we can't forget about egg quality, whether it's table eggs that are being consumed on the human side or the breeding side, then thinking about the embryos and the chicks. These mycotoxins actually can go into the eggs. Some of this research has shown that the emerging mycotoxins like anentians and bovaricin, they can be detected in the eggs just a couple of days after that breeder is consuming them. And actually, once they stop consuming the mycotoxins, it can take maybe 10 days to stop being able to detect that in the eggs. And then you can also see from this diagram here that many of the mycotoxins can go into both the yolk and the white. So really all components of that egg can be impacted, which certainly could have a role on the health of the growing embryo. So then I want to now bring this kind of all together, thinking about all the different symptoms and overall what could this mean to the producer. So what we've done recently at Alltech is we've conducted meta-analysis work. And actually we have published our meta-analysis for broilers, for laying hens, and for growing pigs. And this meta-analysis work allows us to take kind of a body of research and distill it all down into one statistical conclusion. So we can say, we looked at all this research, really what's the overall effect we're seeing of the toxins? And so I'm just going to show the broiler one here in interest of time. But what we did see is we had 25 papers that went into this meta-analysis that were focused specifically on growth, performance, and efficiency, as well as mortality, you can see here. So we were really looking at the performance side. And we did see that there was, when those mycotoxins were consumed, there was a lowering of the body weight gain, there was an increase in the feed conversion ratio of 12 points, and there was also an increase in mortality. And these were all significant effects here of the mycotoxins. What we also were able to do, we took this information from the meta-analysis and we wanted to go one step further, and we wanted to say, how else could we make this relevant? And we wanted to calculate how mycotoxins could impact sustainability. So you can see here, using this information, we could calculate that the mycotoxin challenge increased the carbon footprint by 46.6 tons of CO2 equivalents per 100,000 birds. Now that might be meaningless to you. You might have no idea what 46 tons is. So I tried to put some numbers to that, and that could be equivalent to 32 round-trip transatlantic flights from London to New York, or about 18 cars annual usage or 18 house usage in the United Kingdom. And so really this, just because of this mycotoxin challenge, this really could have a significant impact on the overall sustainability of a farm. So then just really quick, I know there's other talks that are going to get into this more as well, but just a quick overview of some of the mycotoxin management points to remember. Of course, you want to kind of look at your mycotoxin management program as a multi-approach. So first, thinking about testing, thinking about out in the field, from what Dr. Lilburn mentioned, you know, all the things that affect the growth and how it really starts in the field. Knowing the weather, knowing what's sort of been going on in your region. Testing those commodities, testing your feed, knowing your risk. Second, then saying, how could that mycotoxin mixture impact my bird? As well as going and looking at those birds and saying, what are the birds telling me? What are they showing me in terms of their challenge? And then finally, utilizing mitigants that can go into the feed to help protect the animal and prevent the absorption of those mycotoxins. And of course, when we talk about mitigation strategies, there's a number of different strategies. There's the organic products, inorganic products. There's biotransformers, bioprotection. Really, all of these can vary by their modes of action and maybe the mycotoxins that they target. One I just want to quickly touch on is the organic side, specifically yeast cell wall extract. And the way that yeast cell wall extract works is through actually the beta-glucans having structural binding with the mycotoxins. And if I kind of zoom in a little further, that might make a little more sense. So this is an example here with bovaricin, one of the emerging mycotoxins. And we can see here, so bovaricin is in green, and we have the yeast cell wall, the 1,3 and 1,6 insoluble beta-glucans. Those are in the orange and the white and red structures. And so we can see here that actually these come together structurally. It's kind of like Velcro, they link together. Once the structures link, they're held very tightly with a variety of bonds. And so those come together, they're held, and then that can be eliminated from the animal without it ever having an absorption effect and a negative effect on that gut health and the immune system and the internal organs. And so with those meta-analysis work, we've also looked at this effect of yeast cell wall extract, and we've been able to say when we bring that collection of published research together, we can say that in comparison to a mycotoxin challenge alone, we are able to see that the yeast cell wall extract improved the body weight gain of the birds significantly. We also saw a 5-point lowering in feed conversion, and that was a significant response as well as a lowering in mortality. And then we also, again, calculated out that carbon footprint of production, and we saw that it was about half of what we saw with the mycotoxins alone, so about lowering of 25 tons of CO2 equivalents per 100,000 birds. So collectively here, if we kind of bring this whole thing together again, I think getting back to that idea of the original topic of the paper, the anti-nutritional effects, I think they're very similar. Mycotoxins can fall into that anti-nutritional category. They are secondary metabolites. They do have negative effects on the animal, and so maybe that changes a little bit the way you think about mycotoxins in terms of how they're impacting the animal and where they're coming from. Again, collectively, mycotoxins, we do see them globally. They are a common occurrence, I will say, in every different commodity that we test for, in every different finished feed. They have both direct and indirect losses, and with those losses, of course, we need to remember that that does relate to a profitability loss as well for that producer and for that production system. And we can also now begin to look how these mycotoxins impact sustainability. So it's not just something happening just on the farm, it maybe is a much bigger picture thing with mycotoxins. So bringing it back together, you know, if you're going to design a management program, it's always important to remember you need to know what's out there, you need to test for that. We can't see those toxins, so testing is critical. You need to understand how that impacts the animal itself and how much risk you're willing to take in terms of the effects on the animal. And then, of course, go through knowing that first set of information, what do you need to do to mitigate that challenge? So with that, thank you very much. I'm not sure if we have time for any questions, but thank you very much for coming.